All right, guys, today we're going to be solving logarithmic equations. These are equations that have a variable inside of a log expression. And before we get started on it, let's make sure our solving exponentials from the other day is good and that we have the properties of logs we'll need to be able to solve this. So the properties of logs came in lesson 8.2 and solving exponential equations was 9.1. And these are both similar things that we're going to want to be able to do. So start out and try to do number 1 on your own. Solve this exponential equation. And, hopefully we know that the first thing we want to do is isolate the exponential. We want to get it by itself. And so subtracting 5 on both sides is what we're looking to do. And then to undo an exponential, the inverse of exponential is a log. And so we can do a log with the same base, log base 3, on both sides. I had to kind of squeeze this in because the log doesn't go below it. The log is the same level as whatever you're doing the log of. And logs and exponentials will cancel out. And we get r equals, this is saying 3 to what power equals 27. 3 to the third power gives us 27. So that was r is 3. And we can see 3 to the third power is 27 plus 5 is 32. It makes the equation true. This one you need a calculator to do it to 3 decimal places. Hopefully you remember how to do this. Go ahead and find the answer. And I hope what we realize is that there's an exponential already isolated. So we're going to do log base 20 on both sides. So we're going to do log base 20 on both sides. And it's fine to leave the answer as log base 20 of 56. 20 to what power gives us 56? It's an irrational number. And from a math perspective, leaving it like this is fine, although I did ask you to get it to 3 decimal places here. I didn't get my calculator, so let's do it. And let me remind you how to do it in your calculator, how to put in a log. Remember, to get to the logs, we press math, up. We'll get you to a log with any base. It says log base. So math, up. I'm going to write that right here. Math, up. Although if you're using a different calculator, different calculators have different ways of getting there. But you can probably figure it out. You can Google around how to do it on your calculator. Log base 20 of 56. And we know this is going to be an irrational number, but let's go ahead and round it to 3 decimal places. So it's 1.344. The third decimal place rounds up because 6 is bigger than 5. So we look at the thing after 6, and if it's bigger than 5, we round up. So 1.344, the 3 rounds up to 4. So that is what x is equal to. All right, let's see how we do on this one. We need to solve this. And hopefully you started by adding 2 to both sides to isolate the exponential. Here's our exponential thing. It's 8 to a power with a variable inside it. That's what we want to get by itself. And to undo the exponential, we need to do a log. Logs and exponentials are inverses. So log base 8 on both sides. Negative 5n plus 7 equals 8 to what power gets us 64? 8 squared. 8 times 8 is 64. And from here, we can just subtract 7 and divide by negative 5. You're welcome to do that all in one step, guys. I know a lot of you at this point, you can divide by negative 5 because it's multiplying. I know a lot of you feel comfortable doing a bunch of steps at once, and that's fine. So n is 1. Lastly, leave this one, instead of leaving it as a decimal, let's leave this as a simplified expression, which is how we usually want to do it in math. Go ahead and solve this, leaving it as a simplified expression. So we want to add 7. So 5e to the m equals 90. Divide by 5 to get the exponential by itself. That exponential is getting multiplied by 5. So divide by 5. 90 divided by 5 is 18. And last, to undo a exponential with a base of e, we need to do a log with a base of e, and the way that should be written is ln. The natural log is a log with a base of e. That's how we write it, and that will cancel this out, and m is the natural log of 18. We'll often put it in parentheses, but if you didn't, that's okay. All right, so you're going to need that today. You're going to need like some ideas of how to solve exponentials. The other thing you want to be able to do is use properties of logs to simplify this. Combine this into a single expression and simplify as much as possible. And hopefully you recognize that if you have 2 logs adding, you can just combine it into a single log that is multiplying together, 9 times 4. But we can simplify because we can actually do 9 times 4, so we will. 9 times 4 is 36. And then this is saying 6 to what power is 36? And the answer is just 2. Now notice this is a really weird number, and this is a weird number, but if we use properties of logs, it becomes very easy. Now this one you can't just use subtracting right away because of this 1/2. So think to yourself what you should do with the 1/2 and then try to solve this. Simplify it as much as possible by combining it into a single log and simplify. And hopefully you realize that to do this, you needed to put the 1/2 on top here. So log base 3 of 36 to the 1/2 minus log base 3 of 2. And there's a trick here. We should know what 36 to the 1/2 power is. 36 to the 1/2 power means the square root of 36. Fraction exponents are roots. And so we can simplify this. This is square root of 36 is 6. So 36 to the 1/2 power is 6 because to the 1/2 power means the square root. So this is log base 3 of 6 minus log base 3 of 2. And we can combine this into a single log because if there's 2 logs subtracting, that's the same as a single log that is dividing. And just like before, we can simplify this because 6 divided by 2 is 3. So log base 3 of 3, 6 divided by 2 is 3. And this is saying 3 to what power gives you 3? The answer is just 1. All right, simplify this one using properties of logs. Hopefully we recognize that exponentials and logs are inverses of each other. And so 5 to the log base 5 of x, since they have the same base, they cancel out. The answer is just x. Last one, using properties of logs. We want to do this. 125 to the 9th power is crazy. And then you're supposed to say 5 to what power gets you that? Well, that's really hard. But go ahead and evaluate this using properties of logs and it'll go well. Hopefully you recognize that when you have an exponent inside of a log, that can move to the front. That's one of our properties of logs. So this is 9 times log. When something's in the front, it's multiplying. It's 9 times log base 5 of 125. And we can evaluate this log now because this one was crazy to do before. 125 to the 9th power, my goodness. But now it's just 5 to what power gets you 125. So 5 times 5 is 25, times 5 is 125. And so this is 5 to the 3rd power. So this log is equal to 3. So instead of 9 times this log, it's 9 times 3, which is 27. All right, so hopefully you're feeling good about your pre-skills. Let's get into what we're doing today. To solve logarithmic equations, we're really going to have 2 main steps. We want to isolate, which means get it by itself, so get alone or get by itself, a single log. Here, we want to do our best to combine, so sometimes we'll need to combine to make a single log. So if there's multiple logs, we can usually use our properties of logs to combine them. And we want to move anything that's not a log to the other side. So check out how this is going to work. We've got these 2 logs adding, and we've got this minus 5. We'll take the 5 and move it to the other side. And we have this idea that logs can be combined from our warm-up. If you're adding these 2 logs, it can combine into a single log that is multiplying. X times 3 is 3x. We usually put the number in front. And we move the 5 to the other side, and now we have isolated a single log. We got that log by itself. Next, to undo a log. Remember last class, we undid exponentials using logs, and here we're going to undo logs by doing an exponential. Whatever the base of the log is, we're going to do that number to the power of both sides. So 2 to the log base 2, and 2 to the 5th power. 2 to the log base 2 will cancel out because those are inverse operations, and what will be left is 3x. 2 to the 5th power is 2 times 2 times 2 times 2. We want to evaluate that, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power is 32, and now we can just solve. X is 32 divided by 3. There is our answer. It's possible for these to have extraneous solutions, but they're often tricky to check. Does it make the equation true? Instead, what you want to do, I'll put this as 3, check to make sure the solution is, I'm going to say, in the domain. And what we're basically looking for is, remember that log base a of x, the numbers you can't put in for x is x has to be above 0. If you ever try to do the log of 0 or the log of a negative, so log of 0 is undefined, and so is the log of a negative. And so log of negative anything really is undefined. And so if you ever get a solution, you need to at least check to make sure the inside of the log isn't negative or 0. And it's very quick to do. Okay, x is 32 thirds. Is that negative or 0? No. Great, so we're done. But sometimes it will be, and then it will be an extraneous solution. We'll talk about that later. All right, let's do some guided practice. So, is it true that 2 plus 3 equals 5? Yes, I hope we agree. All right, is it true that if we do 2 to the power of both sides, 2 to the 2 plus 3 equals 2 to the 5th power? Calculate this. Calculate each of these and decide, is it true that these are equal? And I hope you saw that they are. Both sides here are equal to 32. 32 equals 32. So doing 2 to the power of both sides is cool. What about if we take the 2 plus 3 equals 5, which was true, and we do 2 to the 2, 2 to the 3, and 2 to the 5? Is that true? And I hope we saw that it was not true. 2 squared is 4. 2 cubed is 8. 4 plus 8 is not 32. So this is not true. And we need to be careful. This is the most common mistakes, to not do this bad thing. If you have a true equation, you can do 2 to the power of both sides and it will still be true. But what you cannot do is, if you have x plus 5 equals 7, you cannot do 2 to this, 2 to this, 2 to this. And this is a common mistake. You also can't do like x squared. Like this doesn't cancel out log. So be careful. You can do 2 to the power of both sides, which is why we need to get our single log. So our goal is to isolate the log, so get the log by itself, and then do the inverse operation. I think you can do this first one on your own. I hope you recognize that the first thing to do was subtract 3, because here's our log. We want to isolate it. We want to get it alone. And the next thing we need to do is divide by 5. And I hope we feel good about these steps from Algebra 1. The last thing is to undo the log by doing an exponential with the same base. Now, it doesn't say what the base of this log here is. So what is the base of this log? And I hope we recognize that the base is 10 automatically if they don't write it. And so we need to do 10 to the power of both sides. Notice that's not the same as doing to the 10th power. We're not doing 2 to the 10th power. That would not cancel out log. We're doing 10 to the power of both sides. That cancels out the log with the same base. This was log base 10, so we do 10 to the power. And so we get x equals 10 squared means 10 times 10, which is 100. At the very end, we want to check it to make sure 100 is not negative inside the log, and it's not. Okay. This next one, here we have 2 logs. Remember what we did during our warm-up. Think to yourself what we need to do here. And I hope we recognize that what we need to do is combine these into a single log. So we're going to combine them using our properties of logarithms. So log base 2 of x divided by 3 equals log base 2 of 12. Okay. Then we've got our log with x isolated. So we're going to undo the base of this. By doing an exponential. We're going to do 2 to the power of both sides, and that will cancel out with log base 2. And on the other side, there's also a log base 2, so that also cancels out. It doesn't always happen this way, but sometimes it does. X divided by 3 equals 12. Last, x is getting divided by 3, so the inverse of dividing is multiplying. And so we get x equals 36. When we put in 36 for x, that does not make the inside of the log negative, and so it will work. Ooh, this is a fun one. Okay, so we've got a log. Notice it doesn't say the base, so the base is all 10 for this one. And we have 2 logs. Guys, there's so many ways to do this. I just want to show you. You could combine these into a single log. You could move this log to the other side and then combine these into a single log. But at some point, you're going to have to use a property of logs and combine them. Let's go ahead and do that here. We're going to do log of, these are subtracting, so it's x plus 2 divided by 3 equals log of 15. To cancel out the log, we need to do 10 to the power of both sides, because this is a log base 10. So 10 to the power of both sides. It doesn't say the base, so it's automatically base 10. So that will cancel out the logs on both sides. Well, that's nice. There's a lot of ones that are canceling out the logs on both sides here. So x plus 2 divided by 3 equals 15. And we need to solve for x here. X is getting added by 2 and then divided by 3. So to undo that using our Algebra 1 steps, we would multiply by 3 and get x plus 2 equals 45. And lastly, we would subtract 2, x equals 43. Again, when I plug in 43, it will not make the inside of the log negative, and so it works. Okay. It doesn't come up very often that it doesn't work, but sometimes it doesn't. Sometimes it doesn't. I want to show you guys, there is always, with these log ones, because we're using properties, we can usually rearrange it and do it another way. I just want to show you, we could have moved this log 3 to the other side. So I'm going to add log of 3 to both sides. So we get log of 15 plus log of 3. And we can do this a different way now. We can combine these. These are adding. And when you add 2 logs, you multiply the inside. So 15 times 3 is 45. And it'll look quite different how we solve it. We'll do 10 to the power of both sides because we've isolated our log and gotten a single log on the other side. And now we'll be at this step we had down below, right? Look, here's that x plus 2 equals 45, even though we did it a very different way. X is 43, just like before. So you can do things more than one way here, and it'll work out. Try number 4 on your own. Hopefully you realize that these logs can be combined into a single log. Log of x minus 4 over 3 equals log of 3. These are subtracting, so you can divide them into a single log. Now we have logs that are isolated. These are log base 10. There's a lot of log base 10 ones here, guys, because it's kind of difficult when I'm making these up. Like any log besides log base 10 is slightly harder to type into a computer. And so I do log base 10 on ones that are typed out more often than other types of log. So these cancel out. We need to get x by itself. X minus 4 is being divided by 3. So we multiply by 3 to cancel out the dividing by 3. X minus 4 equals 9. And then we add 4. X is 13. Again, we check to make sure the inside of the log isn't negative. 13 minus 4 is positive, and so it'll work. We're just making sure it's in the domain. Try this one on your own. Hopefully you notice that these can be combined. Log base 4 of, when you add 2 separate logs, they multiply together on the inside. And then you can do 4 to the power of both sides to cancel out the log. And I hope you realized that 4 to the 0 power is 1. Anything to the 0 power is 1. And then dividing by 3 on both sides will be 1/3. X is 1/3. Okay, this one I want you to leave as a simplified thing and use this symbol for an exponent. You're going to need to use an exponent and use this symbol for the exponent. Okay, so combine these into a single log. Natural log of x divided by 3 equals 5. How do we undo a natural log? Well, this is a log with a base of e. So we need to do e to the power of both sides. That will cancel out the natural log. Now, there wasn't a log on the other side, so nothing cancels out here. This is just e to the 5th power. We leave it as e to the 5th because if it was 2 to the 5th, we would write 32. But e to the 5th is some weird irrational number, and so we just write it as e to the 5th because this is the simplified version. So it's e to the 5th. Lastly, x is getting divided by 3, so we multiply by 3 on both sides. And again, this can't be simplified, so we leave it as 3e to the 5th power. This one's a little weird because just like in our warm-up, this 1/2 on the outside means we can't just add these together yet. What do we have to do here? And hopefully we recognize we move this as an exponent, and so we get 9 to the 1/2 power. And 9 to the 1/2 power means the square root of 9, and the square root of 9 is 3. So all of this becomes log base 3 of x plus, when we moved this here, that was the square root of 9, and the square root of 9 was 3. Log base 3 of 3 equals log base 3 of 21. Now, we could simplify this, but then we would need to move it to the other side, move this log to the other side, combine those 2 logs, and it's a lot more work. It's actually easier sometimes to actually just combine 2 logs together. Even if you could evaluate one, it'll make it easier to solve to get that single log. So go ahead and solve it from here on your own. This is log base 3 of, these will multiply together to make 3x. This is log base 3 of 21. We do 3 to the power of both sides to cancel out the log. And here, there isn't anything left over because we did 3 to the log base 3. It's just 21. And here we get 3x. Divide by 3 on both sides. X is 7. And that inside of the log is not negative or 0. Okay, I should have put some. I guess I didn't put enough on here that had extraneous solutions. All right. Here is, we've got another one. I want you to try this all the way on your own. Here's another one with that 1/2 on the outside. Hopefully you recognize that you needed to move it to the inside. And 16 to the 1/2 power means the square root of 16, which is 4. So when we put this on the inside, this will simplify to natural log of 4. We have two things. So we put this as an exponent. 16 to the 1/2 power was the square root of 16, and the square root of 16 is 4. And so this all became just natural log of 4. We have two natural logs we can combine. This is natural log of x divided by 4 using properties of logs. And we can now do e to the power of both sides. So e to the power of both sides. Now I just want to point out, up above when we did e to the power of both sides, this one didn't have a natural log, so nothing canceled out. We ended up with e to the 5th. But here, the e and the natural log will cancel out, and the e and the natural log will cancel out. And so there won't be any e's left over because it canceled out with the natural log. Whereas up above, there was nothing for it to cancel out with it. On this side, the e and the natural log canceled out, but not this one. And so there was still e to the 5th here. So be a little careful. Don't always just like assume things cancel out. Be thoughtful about it. Multiply by 4. X is, I think this is 256. I sure hope it is. I feel pretty good about that. All right. Now this one, there are a couple ways to do it, but the easiest thing, if there is a power inside of a log and it's equal to a number, there's a really cool trick we can do where we can move the exponent to the front. And this makes it pretty easy to solve. We can divide by 3 on both sides. Log base 3 of x plus 4 equals 2. And then 3 to the power of both sides. To cancel it out, equals x plus 4 equals 9, and 9 minus 4 is 5. Sometimes kids will accidentally like put cubed here, which is wrong, right? That would get you 8 instead of 9. Make sure you're doing 3. Oh, you couldn't see that. Oh no, guys, that's so disappointing. I did 3 to the power of both sides, and I was pointing out that you can't do to the 3rd power. That's not the same as doing 3 to the power of. 3 to the power of cancels out log base 3. To the 3rd power doesn't. But I want to show you there's another way you could have done this, which is you could have done 3 to the power of at the very beginning. So you could have done, hey, like the log is isolated. Why not just do 3 to the log base 3 of x plus 4 cubed? That'll cancel out. And we'll do 3 to the 6th power. Nothing cancels out, but, you know, at least we can do it. And here we'll get x plus 4, oh, you guys can see that? Oh no, x plus 4 cubed equals, doing 3 to the 6th power is kind of hard, right? 3 times 3 is 9, times 3 is 27, 27 times 3 is 81, 81 times 3 is 243? 243 times 3, I think that's 6, is 729. I believe that's 729. That's a big number. It's hard to do powers. And so that's one reason why moving this to the front makes it easier. And now, how do you undo x plus 4 cubed? Well, to undo cubing, we do a cube root. Notice, this isn't 3 to the power of. If it was 3 to the power of, we would do a log. But it's something cubed. Cube root and cubed are inverses. So we're going to do the cube root of both sides. So cube root and cubed cancel out. And here we have to find what times what times what equals 729. And that's a hard question too, right? What times what equals 729? Well, the answer is 9, but it can be difficult to see. 9 times 9 is 81, times 9 is 729, and so x is 5. This is another way to solve it, but it's so much easier if you just take that exponent and move it to the front at the beginning. So 2 ways to do that. One was easy, one was hard. Why don't you guys try this one on your own? A log base 2 of x to the 10th. And I hope you started by moving the 10 to the front. So 10 log base 2 of x equals 5. Divide by 5, log base 2 of x, or sorry, divide by 10 to get the log by itself, 5/10. And we can simplify this. 5/10 is 1/2. We can divide by 5 and divide by 5. And so we get log base 2 of x is 1/2. And the last thing is to do 2 to the power of both sides. Now, because you were doing this by yourself here, I wouldn't be surprised if you said x equals 2 to the 1/2 power, and that's okay. But we can actually simplify this. This is best written as the square root of 2, which in the play posit you would put as like square root of 2. All right, guys, we're going to do something a little different today. I'm going to stop with my explanations, but I'm going to let you try this. And I'm going to give you this file right now to try this. And any ones you miss, just come back to class and ask, like, if you didn't understand why something was wrong, come back to class and ask about it. We'll try that instead so you can get like a little bit of practice on this. So here's the sheet. You'll see a printout of it. I strongly suggest printing it, but if you don't, I'll leave it up on the side. You can click on it anytime, and I'll slowly like move along this so you can do these. So do number 1, do number 2, do number 3, do number 4, do number 5, do number 6, do number 7, do number 8, do number 9, do number 10, do number 11, do number 12, do number 13, and do number 14. The reason we did it like this today is I wanted you guys to get a chance to practice some of these problems and get feedback right away so you could come ask questions rather than just go straight to your homework. I hope you have a good rest of your day, and we are almost done with the year. Man, we're getting close.